Hi, everyone. We're going to continue our conversation about our Unit 8, Day 3, our correlation coefficients, and this is going to be part 2 of our lesson. All right, so in statistics, people often want to see how things are correlated, right? We want to know how things are connected, and it's useful. We can replicate things that go well or avoid things that didn't go well, or simply try to predict patterns in the future. So, what it does when we look at our patterns, right? If we have a strong positive correlation, right? So we want an R value close to positive 1. So let's think about some examples of things that have a positive correlation, right? So two things that go up, right? As one goes up, the other goes up. All right, so one easy example might be something like as the temperature increases, the amount of ice cream cones sold increases. All right, there's one possible example. All right, I want you to try to think about another example. All right, so things that maybe have a negative correlation. So we want R value of -1. So we want two variables. All right, something that's going to, one thing goes up, the other goes down. So something like, I don't know, maybe as the miles driven in a car increase, the amount of gas that's left decreases. All right, I want you to try to think of another example for that. All right, something that has a weak correlation. So something that has an R value of 0. So something like as the amount of sleep increases, the number of letters in your name doesn't change. Right? There's no correlation with those at all. All right, number 7. Which of the following is closest to the correlation coefficient? So we're looking at as these numbers are going up, are these numbers going up or going down? Well, they look like they're going up. So I automatically know it's not going to be number 4. Now, if I want to be precise, I'm going to go to my calculator. Remember, stat, edit. Let's clear those values out. And let's put in these new values. So we've got -2. Whoops, that's all right. -2, 0, 2, and 4. -2, 5, 3, and 11. All right, so stat, calc, linear regression. We're going to calculate. And our R value, 0.88 or so. So the closest one, about 0.89. All right, so let's see. This time we're gonna take this data, instead of just finding the correlation, we're going to make a scatter plot. All right, so in our scatter plot, we know our low temperatures and our high temperatures. And we want to know in the month of April to try to see if there's a relationship between the day's low and high temperatures. All right, so we're going to start by drawing a set of axes. We have our X, we have our Y. So these are our temperatures, our low temperatures, And these are in degrees Fahrenheit. And these over here are high temperatures. And those are in degrees Fahrenheit. All right, so I'm looking at my numbers. I have about 26 to 45. So if I think about how I want to fit these in there, so let's see, what if I do 10, 20, 30, 40? Maybe let's see. If I do 10, 20, oh, that's not going to work. All right, just trying to get an appropriate scale. Sometimes it takes a little while to figure out what that scale is going to be. And it says you might going to use a scale other than 1. I guess we know that. All right, so let's do 5. Let's do 10, 20, 30, 40, 50. And for the high temperatures, 10, 20, 30, 40, 50, 60, 70. All right, what we're going to do is we're going to put a dot at each one of our data values. So we have about 26, 49. There's a dot. 28, 50. Pretty close, also a dot. 30, 57. 32, 54, 34, 60, 35, 58, 37, 64, 38, 66, 41, 63, and 45, 72. So it does look like there's some sort of trend here, right? And so if I want to know if it has a positive or a negative correlation, I'm looking at this trend, thinking about maybe a line of best fit. It's going to be positive since the slope of the line of best fit looks positive. All right, now, do I think we have an R value of closer to 0 or to 1? Now, I'm going to say 1 since the data is close to the line of best fit. Now, I can then take these numbers and put them into my calculator. So stat, edit, let's clear these out. And we're going to enter those data values in there. All right, so 26, 28, 30, 32, 34, 35, 37, 38, 41, 45. My high temperatures, 49, 50, 57, 54, 60, 58, 64, 66, 63, and 72. So stat, calc, let's try linear regression. We're going to calculate, and right there, we were pretty spot on. Our correlation coefficient's about 0.95. All right, let me know if you have any questions, and I hope to see you soon.